Beneath the waves, a symphony of clicks and whistles has echoed for millennia. Now AI has cracked the code. What scientists are discovering is rewriting everything we thought we knew about intelligence on Earth. This changes everything. For centuries, the ocean's depths were an enigma. We heard the songs of whales, but we couldn't decipher their meaning. We marveled at their size, but underestimated their minds. They were simply giants of the deep. Then a shift. The late 20th century sparked an environmental awakening. Researchers began listening, really listening. They recorded the haunting melodies of humpback whales. These weren't random sounds. They were complex, evolving compositions. Songs of the humpback whale became a global sensation. It ignited a movement, saving these creatures from the brink. Bioacoustics emerged, but answers remained elusive. Early researchers toiled for hours, painstakingly analyzing whale vocalizations. Mating calls, distress signals, simple communication. We could only guess. The data was overwhelming. Our senses limited. Enter Dr. David Gruber. He envisioned a new approach. He looked to space, to the search for extraterrestrial intelligence, said he. What if alien intelligence wasn't among the stars? What if it was right here in the form of a whale? A radical idea. The birth of Project CETI, the Cetacean Translation Initiative. Dr. Gruber assembled a dream team. Marine biologists, computer scientists, linguists, roboticists. Their mission, a two-way dialogue with another species. More than just ears were needed. They needed a way in. This was not your average scientific team. It was a fusion of brilliance. Their shared goal, to crack the code of whale communication. Impossible, maybe. But this unconventional alliance was exactly what the project demanded. Whale voices are complex. No single discipline could unlock them. Collaboration was the engine of Project CETI. People like Shane Giro, a marine biologist, dedicated a decade to studying a single sperm whale family. He knew them by name. He watched them grow. His intimate fieldwork became the bedrock of Project CETI. Then came the missing piece, artificial intelligence. Translation of whale communication. Once a researcher's wildest dream. Technology held it back. But a breakthrough was looming. Around 2019, a realization. The technology existed to build an underwater recording studio. A studio capable of translating the language of sperm whales. Like landing on the moon, this ignited the project. Suddenly, the impossible felt within reach. Dominica became the heart of the project. Volcanic landscapes, deep waters close to shore. Sperm whales thrived there, returning families year after year. The same island where Shane Giro's decades of work began. Project CETI officially launched in 2020. A massive boost, $33 million from the TED Audacious Project. Funding to build an incredible team. To create a 20x20-kilometer underwater listening and recording studio off Dominica's coast. AI could now hear the whales, identify who was speaking, and understand the social context. The technological bridge was complete. Field scientists and tech experts united. Biologists provided the deep knowledge. Computer scientists the tools and the power. Hand-on research guided the technology. The technology uncovered new discoveries. This collaboration was Project CETI's greatest strength. They tackled the problem from all angles. How do you collect sound in the deep without asking a whale to wear a mic? Sensors, arrays of hydrophones, underwater microphones, placed on the ocean floor in a grid-like pattern, constantly recording, like a room filled with microphones. detecting every sound, from a pin dropping to the softest whale call, pinpointing the location of each click, identifying the specific whale making the sound. A robotic fleet, autonomous drones, robotic systems sent to get close to the whales, non-invasive suction cup tags, packed with sensors, recording audio, movement, heart rate, social interactions. Who was saying what? And why? The hydrophone network provided the words. The tags, the context. Was the whale hunting? Socializing? This behavioral data gave the AI vital clues. Mountains of data. Previous research. A few hours, a few days of whale sounds. Project CTI. Millions, billions of vocalizations. The largest library of whale sounds ever created. AI models need huge data sets. They learn by example. The more examples, the smarter they become. This wasn't about finding a few key phrases. It was about capturing a complete language. The data streamed in. Clicks, whistles, songs, raw data without meaning. An ocean of information waiting to be decoded. The real magic happened when this ocean of sound was fed into the machine learning models. Mere noise transformed into the building blocks of a language. The human ear hears only a confusing jumble. The first challenge, turning raw audio into something AI could interpret. Sound into a picture, a spectrogram, waves of the ocean transformed into visual charts. AI could now see the whale sounds. Its first task, to sort through these images. Identify the codas, the specific sequences of click sperm whales used to communicate. Ignore the background noise, turning an invisible sound into a visible pattern. The crucial first step, machine learning as a modern-day Rosetta Stone. Advanced AI technologies, deep learning, neural networks, designed to learn like humans, recognizing patterns in vast amounts of information. The AI wasn't given a list of rules. It was trained using millions of whale codas. Studying these, the system slowly found patterns. Which sounds appeared together? How did they change in different situations? What might they mean? Like learning a new language. The technologies noticed tiny differences in the clicks. Variations in rhythm, tempo, details undetectable to the human ear. A toddler learns a language. The computer was doing the same thing. Faster, with a dataset a single human could never analyze. The sheer scale gave the AI the power to find hidden patterns. The core discovery, the sperm whale's language, was even more complex than imagined. Not just a simple set of messages. A system that works like a phonetic alphabet. Variables, rhythm, tempo, ornamentation. Extra clicks at the beginning or end of a coda. Combining these creates an insane amount of unique words or messages. A slow, steady rhythm might mean one thing. Speeding it up, adding an extra click, could completely change the meaning. The idea that only humans have a complex linguistic system was shattered. Whales were using a system with many parts, rearranged to create an intricate vocabulary. A window into their syntax. But what did it all mean? Scientists expected a simple, direct language. Commands, survival instructions. The AI revealed something unexpected. The patterns weren't tied to simple actions, but to social context. Whales communicate in complex and sometimes personal ways, reflecting their closeness and social lives. Less a code, more a conversation. Subtle variations within the clicks, like vowels in human language. A sophisticated system of rubato. Fine-grained changes in rhythm. Slight pauses, quicker tempos, basic words molded and shaped to express different emotions or intentions. Linguistic sophistication challenged the idea of human uniqueness. Tied to social identity, different whale clans use distinct dialects. Like regional accents, the AI could identify families by their speech patterns. Not just a universal code, a living part of their culture, passed down through generations. AI has given humanity a window to a culture we never knew existed. Communication patterns, social connections, identity, shared history. Not just translation of words, knowing the ins and outs of marine life. But what could this new development mean for the future? For decades, we've only listened. Now we understand the structure of their language. The next phase of Project CETI, moving from listening to talking. A real-time communication system. An underwater chatbot. Not teaching whales English. Using the AI-discovered patterns to create messages in their own language. A specially designed speaker plays a specific sequence of clicks. Hopping for a response. Simple interactions. Greeting a whale. Asking about a particular object. A two-way conversation between two different species. Ethics of interspecies dialogue. Should we be talking to them? Are we obstructing the balance of marine life? Introducing our technology into their world. Disrupting their natural social structure. Changing their language. The Project CETI team takes this very seriously. Not just a technical goal. Respect for the whales and their culture. Conversation on their terms. In their language. In their own time. In 2023, the team had the first intentional human-whale interaction. A diver played a sperm whale coda using an underwater speaker. A whale responded with the exact same coda. A direct back-and-forth exchange. Not just a recording. A conversation. A single small exchange. Monumental significance. Their understanding of the language was accurate enough for basic communication. Not just a scientific breakthrough. A positive sign. We might one day be able to talk to other minds on our planet. Observing to participating. Listening to interacting. Communicating with another species. Implications extend far beyond the whales themselves. This technology could rewrite our place in the universe. Project CETI is forging a new frontier for biology, limited by our ability to observe and interpret. AI as the translator. Unlimited opportunities. Structures of their lives, communities, intelligence. Transforming how we see animal communication. Revealing complexity and social value. Explaining wonders of the world. Answering science's biggest questions. Revolutionizing the very nature of intelligence itself. This research connects to space. CETI derived from SETI. Scientists scanning the cosmos for radio signals. What if they've been looking for the wrong kind of message? The whales give us a blueprint for extraterrestrial contact. The algorithms developed to decode whale language could be used if we ever encounter an alien civilization, communicating in a way completely foreign to us. We now have a proven strategy. The principles of using AI to find structure in a complex, unknown signal are universal. Not just about communicating with whales, preparing for communicating with anyone, anywhere in the universe. The work of Project CETI brings us back to Earth. Understanding the whale language. A new level of empathy and conservation. Whales as a species to be harvested, then saved, but always from a distance. Forced to confront their intelligence and personhood. Concerns about their families, culture, world. Not just animals in the ocean. Beings with thoughts, feelings, and a history. Strengthening the case for their protection and the health of our oceans. A rich, complex social life. A personal, emotional reason to care about the marine environment. It's only the beginning. A new way to see the world and a new role to play in it. Expand research to other whale species. Orcas. Refine AI with new algorithms. A global movement. Scientists using AI to study animal communication. A world of complex language we never knew existed. More than just science. Building a bridge between our species and theirs. A shared future on a shared planet. They have a lot to tell us about the health of the ocean. We are finally learning how to listen.